Hello students, in today's class let us revise the next chapter, linear inequalities. It's a very easy chapter and very few concepts are there. So first, what is meant by an inequality? When we have not equal to, when we have less than, greater than symbol like this, we call that particular statement as inequality. Only if we have equal to sign, we will call it as an equation. So there are many algebraic expressions or statements which involve other than equal to sign, like less than, greater than, less than or equal to, greater than or equal to. So these statements are called linear inequalities. Linear means degree 1. So in this chapter we are going to see degree 1 polynomials. Okay, degree 1 inequalities. So mainly what are all the rules should be followed or remembered while solving an inequality? Rule 1 is equal number may be added or subtracted on both sides. It will not affect the sign of the inequality. Similarly, both sides of an inequality can be multiplied or divided by the same positive number. The sign will change, the inequality will change only if we perform an operation with a negative number. You should remember this. If you are going to add a positive number on both sides, it is not going to change the meaning of the equation. But when you do an arithmetic operation with negative number, it will reverse the inequality, especially with multiplication, not with addition or subtraction. While adding or subtracting the inequality, it is the sign, the inequality is not going to affect it. I'll show you few examples. See, 3 is greater than 2. We have added plus 2 on both sides. Even if we add a positive number, we got 5 and 4. Yes, 5 is greater than 4. It's true, right? And we have subtracted a positive number. So when we add or subtract a positive number, the inequality will remain same. If we add or subtract a positive number, the inequality will remain same. When we divide a positive number, again the inequality remains same. But when we divide by a negative number, what will happen? See, we got minus 3 greater than minus 2, but actually minus 3 is less than minus 2. So when you divide by a negative number, you have to immediately change the inequality. You have to remember this. Then we have seen how to solve an inequality. See the first question, solve 24x is less than 100 when x is a natural number and x is an integer. How to solve this? So as we solve for an equation, we have to solve for an inequation as well. Try to isolate the variable and bring the remaining things to the other side. While performing this action, remember the rules which I told just now. Now when you are multiplying or dividing by a negative number, the inequality will get reversed. That alone you have to remember. Otherwise you can do the same procedure what we do for an equation. So 24x is less than 100. To isolate x, we are dividing both sides by 24. So we got x is less than 25 by 6, which is nothing but 4.2. Now we have to give the solution set when x is a natural number. When x is a natural number, we know the number system is 1, 2, 3, 4, etc. So less than 4, now what are all the 4.2 means what are all the possibilities for x? 1, 2, 3, 4. When x is an integer, the number line will be like this. Integer, now it will include both positive, negative numbers along with the 0. So when it is strictly less than 4.2, you should not include 4.2. Right? So that's why we got 4 here. Here x is an integer means less than 4.2 means it will include all the negative numbers as well. Right? So the solution set is etc. minus 1, 0, 1, 2, 3, 4. You can give this in a roster form, or else you can express it as a intervals also. The solution set can be expressed in a intervals also. Right? So similarly the next problem, see here we got x is greater than minus 2. So the solution set is expressed as an interval. Already we have learnt what is meant by open interval and closed interval. Since it is strictly greater than, we should not include minus 2. So it is expressed as an open interval minus 2 comma infinity when it is a real number. Right? When it is an integer, see when it is an integer it can be expressed as a roster form only. When it comes to real number only, you should express it as an interval because it involves all the numbers, right? So when it is an integer, you have to express it in the roster form only. So x is equal to minus 1, 0, 1, 2, etc. because it is strictly greater than minus 2, which means this side of the number line, right? Hope you people recalled how to solve a linear inequality. Next, we have seen few problems like this where we have the variable on both the sides of the inequality. This is also like the same way. Bring all the like terms to one side and perform your action. Before bringing the like terms, balance the equation by adding or subtracting the same numbers. That's what we have done for the previous problems, right? So to plus 3 we have, so subtract minus 3 on both sides, then or else you can bring the numbers to the other side also instead of balancing this. If you bring plus 3 to the other side, it will become minus 3. So 7 minus 3 has become 4. If you bring this, it will become minus x. Now minus x is less than 4. Now we need x. So we are going to multiply by minus 1 on both sides. When we multiply by a negative number, the inequality will get reversed. So x is greater than minus 4. Right? And it is for real x, so you can give your solution set, which is minus 4 comma infinity. Again I am repeating, only for real numbers you have to give it in interval. Yes, when you have a question like this also the same way, take LCM and simplify it for x. Next we have seen how to give the solution of the inequality on number line. If we get the solution set as x is less than a or x is greater than a, put a circle on A and dark line to the left or right of A. If x is less than or equal to or greater than or equal to, put a dark circle on A like this. So when that number is not included, you have to put an open circle. If the number is also included, you have to put a dark circle, and this side or that side of the number line, you have to mention it with a dark line like this. Like this only you have to express the solution on a graph on a number line. Solution of the given question on a number line. Okay, then we have also seen few statement problems, applications. So according to the statement, you have to frame your inequality as we frame our equation. Then you have to solve. When we have at least, remember, greater than or equal to. At least means greater than or equal to. I'll show you an example now. See the 23rd question. Find all pairs of consecutive odd positive integers, both of which are smaller than 10 such that their sum is more than 11. Now how will you frame your equation now? Let x be the odd positive integer. Then in the question it is given pair of consecutive odd integers. So if x is the first odd positive integer, the next odd integer is going to be x plus 2. Right? So according to the question, both the integers are less than 10, smaller than 10. So x is less than 10, x plus 2 is also less than 10. Right? And it is given the sum of the numbers, both the numbers is greater than 11. So x plus 2 is greater than 11. Now how you will solve this? Here we got x is less than 10, here x plus 2 is less than 10. So simplify, we got x is less than 8. X should be less than 10 and x should be less than 8. So we will go for x is less than 8, because if x is less than 8, automatically it will become less than 10 as well. Right? Now keep it aside. The other side we have x plus 2 is greater than 11. Now if we simplify, we got x is greater than 4.5. Greater than 4.5 means this side. Right? So x is less than 8 and it should be greater than 4.5. Also x is an odd positive integer. So it's a positive integer. It's not a real number system. Right? So only possibilities for x are 5 and 7, because it should be odd integers. Right? So the only possibilities are 5 and 7. Hence the consecutive odd positive integers are 5 and 7 or 7 and 9. Okay. Why we have taken 7 and 9 also here? Because x should be less than 8. Right? The second integer, we don't have any constraint there. Second integer should be less than 10. Right? So x should be less than 8. So it can be 7 also. Right? So the only possibilities are the odd number should be 5 or 7. If it is going to be 5, the next integer is going to be 7. If it is going to be 7, the next integer is going to be 9. Likewise, you have to give your solution based on all the inequalities what you had for x, right? Hope you recalled all these things. So like this, you have to frame the inequality for the given constraint or given situation, and then you have to solve for it. If you get 2-3 inequalities for x, you have to combine everything. For the better clarity, draw a number line, mark it on the number line, so that you will get a better clarity. Without confusion, you can give your solution set. Next, we have seen how to give the graphical solution of linear inequalities in two variables. As we know, the graphical representation of a linear equation in two variable is a straight line, right? Now we are going to see how to represent a linear inequation, how to give the solution of a linear inequalities in two variables. We know it's a straight line, right? If it's an equation, it will be a straight line. So when we get a straight line, you have to divide it into the half plane. Either you can have it as left or right if it's going to be straight. If you are going to get a slanting line, you take it as the upper half and the lower half. Okay. Now let me give you the glimpse how we have solved. If this is a inequality, take it as an equation first. X plus y equal to 5, and draw the graph of this linear equation as we used to do normally. What we will do, assume some values for one variable and find the corresponding value of the another variable by substituting in the equation, and then plot it in the graph. -2, 7, 1, 4, 2, 3. You can take any three values, that is enough. One negative, positive, two positive, or negative, 0 and positive. You can take it in your own way. So take three values and plot it in the graph, right? So we got a line like this. After drawing the equation, you split the plane into two. 1 and 2. It is not necessary this should be 1, this should be 2. It's your wish. You can choose one half as 1, the other half as 2. The second step, what you have to do is choose a point which is not on the line. Choose a point which is not on the line. If the line is not passing through the origin, better option is go for the origin, because your calculations will become easier. If the line is not passing through the origin, choose a point as the origin which is not on the line, so that your calculations will become easier. Now the line is not passing through the origin, so I am going to choose origin as my point now, 0, 0. So what you should do after choosing a point which is not on the line, substitute that point in the inequality, not in the equation, inequality. So 0 plus 0 is less than 5, which is 0 less than 5, which is true. So when a point satisfies the equation, we will tell that point lies on the line. The same way, when a point satisfies the inequality, we will say that side of the plane is the solution region. Alright, for inequality, we can give only the solution region. So here 0, 0 satisfies the inequality, so the region of the plane where 0, 0 lies will be the solution region of the given inequality. So this plane 1 will be the solution region of the given inequality, excluding the points on the line. Why we are excluding the points on the line? That's why we have denoted it in a dotted line. Because the inequality is strictly less than. If it is less than or equal to, you have to draw it as a thick line. When it is strictly less than, you have to draw it as a dotted line, and when you are giving your solution, you have to write excluding the points on the line. If it is strictly equal to, you have to write including the points on the line. Alright, let us see another example. Y is less than -2. When we take y is equal to -2, we will get a line like this. Then divide it 1 and 2. Now again we have to choose a point which is not on the line. Now it's not passing through the origin, so we can take 0, 0. So if we put 0 in the inequality, 0 less than -2, which is false, because 0 is greater than -2. Okay, 0 lies in the first region, therefore it is not a solution region. Okay, now this region 2 is the solution region, therefore you have to write half plane 2 will be the solution region, excluding the point on the line. So it all depends which region you are going to choose. You can name this as 1, this as 2, it's your wish, but when you are giving your solution, if you have taken this as 1, you have to write half plane 1 will be the solution, excluding the points on the plane. It doesn't matter which plane you are going to name it, it's just the naming to give your solution, right? Next, we have seen how to give the solution region if we have more than one inequalities. Here see, we have three inequalities. 3x plus 2y less than or equal to 12, x greater than or equal to 1, or then y is greater than or equal to 2. This also can be done in the same way as we solve the solution region for the system of linear equation. So what we will do, first take it as a straight line, take it as an equation and draw a line for all system of linear equations, right? So we have taken 3x plus 2y equal to 12 and we know how to draw the graph. Solve it for a variable, then choose 3 values for your x and substitute in the equation and find the value for y and plot it in the graph. Alright, since it is less than or equal to, we have drawn it in a thick line. Then draw the line of x is equal to 1. X equal to 1 is this. And what is y equal to 2? Y equal to 2 is this. So we have drawn all the 3 lines. Right? Now we have to choose a point which is not on the line. Now we are going to choose a point 0, 0. All the 3 lines are not passing through the point 0, 0. So we are going to choose a point 0, 0 which is not on the line. Now first, if we substitute 0, 0 in the first inequality, it satisfies. Okay, so this is our first line and 0, 0 lies here. Therefore, it satisfies. Therefore, this part of the line is going to be the solution region for the first inequality. In the next inequality, if we substitute, we are getting a false result. 0 greater than or equal to 1, which is false. So whereas x is equal to 1, x equal to 1, 0, 0 lies this side of x equal to 1, okay, which is false. Therefore, this side of the equation will become the solution for x equal to 1. So for this line, we got this region. For x equal to 1, we got this region. And for the third one, 0 greater than or equal to 2 again, which is false. Y equal to 2 is this line and 0, 0 lies this region of the y equal to 2, but we got a false statement. Therefore, this region is not a solution. Only the upper region will be the solution. So for this line, we got this way, and for this line, this side, and for y equal to 2, we got this. So shade all the region and see where we got the intersection. So this intersection region, you have to shade it in pencil and you have to show the solution region in your graph. So this intersection region will be the solution region for the given system of linear inequalities, including the points on the line. Why including the points on the line? Because we have less than or equal to, greater than or equal to on the inequalities, right? So you have to give your solution like this. Of the given system of linear inequalities is represented by the common shaded region, including the points on the respective lines, right? Hope you people recalled all these things. And in the miscellaneous exercise, again we have solved. When you have two-side inequality, take two things separately. Even you can solve by taking it at a stretch. So you can arrive at a solution set like this, or else you can solve it separately. Take this inequality first, solve for it, find one side limit of x, and take this thing and solve it, and take the other side limit of x, and then give your combined solution set like this. And when the range of x is not, the value of the x is not mentioned in the question, we will take it as a real x only, so that you can give your solution in the intervals. If it is mentioned as integer or natural number, then you have to give your solution accordingly. If it is not mentioned for the entire chapter, we will take it as a real x only, right? So that's it for linear inequalities. Do these questions from all the exercises as homework, so that you will get practice towards the thing what we have recalled right now, right? Thank you, students. If you have doubts, you can ask me.